In this problem, we consider that we have a voltage source, a pure sinusoidal voltage source, supplying a load, whereas the load current is expressed in terms of I of t is having not just the DC or fundamental components of the current, but it also has higher order harmonic currents. In this particular case, we would like to calculate what are the RMS value of the source voltage and source current, and power absorbed by the load, power factor, distortion factor, and various factors that quantifies the power quality in this particular case. In order to do that, the first thing is the RMS value of the voltage and current. Now we see that the voltage is just V max, that is 300 cos omega t. Here we can see that our value of omega is 2 pi f, considering that you have a frequency of 60 Hz, that is what is approximately considered as 377. So we have that as V of t. Now 300 is basically maximum value of the voltage. So now if you have your V max, which is given as 300 volt, then your RMS value is V max upon root 2. So that value of the voltage, we will get it as 212. In order to get RMS value of the current, now we can see that the current does have a DC component, that is 6, and also fundamental frequency component and higher order frequency components. In that case, the value of current RMS is expressed as square root of I0 RMS square plus I1 RMS square plus I2 RMS square plus I3 RMS square. Now whereas the I0 RMS is just 6 for us, so it is going to be 6 square. RMS value of a DC current is just that DC current itself. Now we have 10 cos 377t plus 30 degrees. The maximum value of the current in this fundamental case is 10. So RMS value of that current is going to be 10 upon root 2. So whole square is going to be I1 RMS square. And now the next one is 5 cos 754t plus 45 degrees. In this case, the RMS value of current is going to be maximum value, that is 5 upon root 2, and that RMS square is something like this. And the next one is the last current, that is 2 cos 1131t plus 60 degrees. In this case, the RMS value is 2 upon root 2 whole square. So if you substitute all these RMS values of the currents and find the square root of that, then we will be getting the value of the current, that is 10.025 amps. This is RMS value of the current. But if you want only RMS value of the fundamental current, that is only this value, you can see that this is what is the fundamental frequency and the corresponding current. Then you can write down that as I1 RMS. I1 RMS is just 10 upon root 2 itself. So that's what is I1 RMS for us. Now we'll be using all these three numbers: the RMS value of the voltage, RMS value of the current, and RMS value of the fundamental current to calculate the rest of the factors. After calculating the RMS value of the voltage and RMS value of the current, if you want to calculate the power absorbed by the load, that is P load, will be corresponding to only fundamental value of the voltage and fundamental value of the current. That is V1 RMS, I1 RMS, and cos of theta minus phi. Whereas this theta is the angle of voltage and phi is the angle of current. Since we don't have voltage that corresponds to any other frequencies, we also don't get any power that corresponds to different frequencies. If you substitute these voltages and currents, V1 RMS is 300 upon root 2 for us, and I1 RMS is 10 upon root 2 for us. And then cos of, we can see that the voltage doesn't have any phase angle, 377t. There is no phase angle, so that is 0. And current does have a phase angle of 30 degrees. So then we'll be able to get the value of the P load as 1.299 kilowatt. After calculating the value of the power, if you wanted to get the value of the power factor in this case is actually cos of theta minus phi multiplied by I1 RMS upon IRMS. Here in this case, since we don't have just the current that corresponds to the fundamental value, we also have the currents that corresponds to the higher order frequencies. There will be some deviation in the power factor because we are drawing some harmonic current here. So the value of that is cos of minus 30 degrees. You have seen that. Whereas the value of I1 RMS is 10 upon root 2 for us. The value of IRMS is 10.025 for us. If you simplify and substitute this number, the power factor is going to be 0.6108. After that, if you wanted to calculate what is the distortion factor of the load current, distortion factor of the load current is just talking about this particular value. That means if you want to calculate the distortion factor of the load current, that is going to be I1 RMS upon IRMS itself. Now we know that I1 RMS is going to be 10 upon root 2. IRMS is 10.025. So if you substitute and calculate what is the value of that, you will get that as 0.7053 as the distortion factor in this case. Another power quality index that we need to calculate here is the form factor. So form factor is basically calculated as the RMS value upon the DC value of the current. So now RMS value of the current is given as 10.025. And then if you wanted to get the DC value of the current, you have an expression for the current. Just that 6, the constant value of the current itself, is the DC value, because when you take the average of this particular current, all the sinusoidal currents will turn out to be 0. So this is going to be 6 for us. So the value of the form factor is going to be 1.6708 for us. Next one to calculate is the ripple factor of the load current. Now if you want to get the ripple factor of the load current, then it is going to be square root of form factor square minus 1. We already have the value of the form factor, and that is 1.6708 square minus 1. And if you calculate what is the value of the ripple factor, and that is 1.3385 for us. And after that, if you wanted to get what is the total harmonic distortion factor, the total harmonic distortion factor, THD, is going to be square root of 1 upon distortion factor square minus 1. We already have the distortion factor being calculated, that is 0.7053. So if you substitute that 1 upon 0.7053 square minus 1, then you will be getting the value of that total harmonic distortion as 1.005. So this is how various power quality indices for a given voltage and current can be calculated